right, so we are starting with section 7.2. And as I said, we have all of our integrals, integral rules that we should be able to use for now. And what we look at today is what's called integration by use substitution. And we came across, before we do example 1, we came across an example or a homework problem from one of the last homeworks that looked something like this. Yes? You guys remember this one? I had a lot of people come and ask me about this one. And in the section that we were doing at the time, they were requiring you to kind of think backwards as to what I started with to get that derivative. Okay? And that takes a good bit of thought. So you have to think, well, this is 2 times 2x plus 1 to the what? Negative 3. Well, if I have this to the negative 3, then what must I have had before I took the derivative? To the negative 2. So I must have started with 2x plus 1 to the negative 2. Well, let's take that derivative and see what we get. We're still trying to get back to this. So if I take the derivative here, what do I get? Negative 2 times 2x plus 1 to the negative 3. Thank you, chain rule, times 2. So if I just simply had this, then I would have ended up with negative 4 times 2x plus 1 to the negative 3. Well, is that what we were looking for up here?
No.
No. So what would I have to multiply this thing by? Negative 1/2. Okay? So when we took the derivative of that, we would get this, and that's the only way you had that you could think backwards to get to what that integral would be. Okay? Well, what happened here is when we saw the derivative, we saw that it required chain rule. So what we learned today is a process to help us deal with functions that the derivative was taken using chain rule, or it was a composition of functions. So a cleaner way to find an integral like this one that we ran into in the previous section. All right, so given that, that's where we're headed today. And let's start with just a little review. So this first example just gets us going in the antiderivative direction. And what do we have here? I'll make it a little bigger for those in the back. Evaluate the indefinite integral. Remember, when there are no lower and upper limits, it's called the antiderivative or the indefinite integral. And how would we do this one? Help me. I guess we can write it down first. X cubed over 3 plus cosine x. Very nice. Because the derivative of cosine x is negative sine x, and then plus b. On every indefinite integral, we will have a plus b. Okay? All right. So now let's move forward. Make sure we're all, I won't go until we're all ready. On problems like this, you might be asked to find the general solution, and that just means take the antiderivative and put in your plus b. If you are asked to find the particular solution, then they would have to give you a point, so that you could plug in for x, plug in for y, and solve for that c. Okay? All right, let's move on. Now we're going to do our own investigation. All right, so let's take a look here. Before we get into U sub, we need to look at some problems where the variable of integration determines how we are going to approach the problem. Okay, so in this one, it says let f of x equal x cubed plus 1 and let u equal x squared. Find each of the following antiderivatives in terms of x. So our answer in the end will have x's in it. Final answer will have x's in it. That's what that means. Not used. Okay? All right. Well, part A says take the antiderivative of f of x dx. So that's just x cubed plus 1 dx. And we get what? X to the 4th over 4 plus x plus b. Similar to the problem we just did. Now part B says, I would like you to find the integral of f of u du. So they're telling us to integrate with the variable being u, and then go back to x. All right, so let's do that. So, what is f of u? U cubed plus 1. And we are doing that with respect to u. And we get u to the 4th over 4 plus u plus b. But we're not done because they told us all of our answers should be in terms of x. So this says now go back to your x. So what is u equal to? U is equal to x squared. So we have x squared to the 4th over 4 plus x squared plus b. What's that final one mean? The integral of f of u dx. Solomon, what do you think?
You have to differentiate with respect to x. That's the same as the integral of f of x squared dx.
Okay,
So just
so
put in the x squared right away.
put in the x squared right away
X
into,
x plus 1.
right, so here we will do f of u is u cubed plus 1. What? Yeah, go ahead. But we want to take the antiderivative in terms of x, so we immediately have to replace our u with x squared. So that is x squared cubed plus 1. And that's what we are integrating, the integral of x to the 6th plus 1 dx. Giving us x to the 7th over 7 plus x plus 2. Okay? So it makes a difference what our variable of integration is as to how we will proceed. So just something to keep in mind as we move forward. Let's move on. All right, this is the first one that we will need u substitution for. All right, so the idea behind u substitution is we have an integral that would be difficult to take in its current form. So if we can find a way to rewrite it in terms of another variable, such that it would be easier, then we could take the antiderivative and then go back to x's in the end. Okay, so use substitution, just like you've done in Algebra 2 and Pre-Calc. We do that to make a simpler problem, and then we go back to the variable we need to finish the problem. So, for use substitution, this is really the second integration rule, and for use substitution, if you are deciding whether or not you can use it, because it doesn't work for every integral, what you are looking for in the problem is a function and its derivative to show up in the problem, or in the integrand. function and its derivative. So if we look at this integral, can you see within this problem a function and its derivative? What do you see? Sine and cosine. They are derivatives of each other, correct? The function and its derivative. So the function could be sine x and its derivative cosine x. Or the function could be cosine x and its derivative negative sine. It's okay if it's off by some multiplier constant, because we can adjust for that. Generally, with use substitution, you want to, and this is generally, it changes a little bit on different types of problems, but your first thought is to choose the most inside function to be your u. So for example, it's easier to see on something like x squared plus 3 to the 5th. There is an outside function and an inside function. And what I always say, so we have an outside function and an inside function. And the outside function is something to the 5th. And the inside function is what? X squared plus 3, yes. X squared, yes. Now, another little hint, do not separate things that are added or subtracted for your u. You want to usually just take the sum and difference as the whole function. All right, well, let's say we had sine of 2x. What's the outside function? What's the inside function? Sine of something is our outside function, and our inside function is 2x. All right, what if we had e to the cosine x? What do you think? E to the something is the outside, and what's the inside? Cosine x. So generally speaking, we would be taking the inside function to be our u. All right, so since my final example here was e to the cosine x, let's go do this problem up here. So the most inside function is this cosine x, so we're going to say let u equal cosine x. Now, our goal is to rewrite this entire integral with u's and du's and no x's. That means that we will need a du. Well, du is the derivative of u times dx. So du equals, what? What's the derivative of cosine x?
Negative sine x.
Negative sine x. Dx. Or du dx is negative sine x, and you can move the dx over. But this is the general form that we want to be in every time. Okay, well, that means that I could rewrite this as e to the u, but what I have left is sine x dx, not negative sine x dx. Correct? I want a perfect match. I want to be able to replace sine x dx with exactly what it's equal to. So what is sine x dx equal to? Well, I'm off by this negative, correct? So let's divide by negative 1 on both sides, and I have negative du is equal to sine x dx. Well, that negative, any constant that we move so that we can match our integrand, that constant can come out in the front as a negative out in the front. And then, take care of your u first. We have e to the u times negative du, well, the negative's out front. So this integral is equivalent to the integral of sine x e to the cosine x dx. Well, is this an easy integral to take? Indeed. All right, so our negative stays out in front. We take the antiderivative of e to the u, and what is that? Also e to the u, plus b. And then finally, now we go back to x. This is negative e to the, what is u? Cosine x plus b. So that is the antiderivative of this function. How could I check my answer?
Take the derivative.
We could take the derivative. So let's do that. Negative e to the cosine x, what's the derivative of that?
E to the cosine x
It is e to the cosine x
times negative sine x.
times negative sine x. Derivative of a constant is 0. So here we have sine x e to the cosine x, which is exactly what our integral was to begin with. Questions? So now you've seen our total goal here is to rewrite it in terms of u's and du's, integrate it, and then go back to x's. All right? Questions on this one? Just your first one? Let's try a few more. So, the integral of x squared root 5 plus 2x cubed. What's our most inside function? 5 plus 2x cubed. So let's let that equal u. Now sometimes with u substitution, you choose a u and it doesn't work. Choose a different u. Go back and try something else. All right. So we'll let u equal 5 plus 2x cubed. What is du? Nope, derivative.
Oh, D.
Du is the derivative of this line. So 6x squared dx. Very good. Don't leave off the dx. We're replacing everything that's in the original integral. All right, well, I see that I would have the square root of u. I see my dx taken care of. I see my x squared taken care of. What's the problem? The 6 is the problem. How do I get it out of the way? Divide by 6 on both sides. So I have 1/6 du equals x squared dx. So now will I account for everything in the original? I will. So a 1/6 comes out in front. Integral of what? Square root u times du. 1/6 du replaces x squared dx. And the square root of u replaces the square root of 5 plus 2x cubed. Yes? All right, how do we integrate this? 1/6, the integral of, how do we rewrite that so it's easier? U to the 1/2 du. Now we do our power rule, leave that 1/6 out in front. What is the antiderivative of u to the 1/2? Yep, so I'm going to write it as 2/3 u to the 3/2. You'll see me write it that way quite often, just so I'm not dividing by a fraction. And I need a plus b, correct? All right. So what do we have in front? 1/9. And what is u? 5 plus 2x cubed to the 3/2 plus. Any questions on that one? Okay. All right. Let's see. Try that one. And I will tell you, we don't know the integral of cotangent, so our immediate step would be to think of this in terms of sines and cosines. Give it a try. Remember, you're looking for a function and its derivative. So keep in mind where you may choose incorrectly the first time. And that's okay. Ideas on our U? Louder? Yeah. 7x, we certainly could do that, because the derivative of 7x is 7, just a constant. But I will tell you, if you only choose 7x, let's look at what would happen. Let's say u equals 7x. du equals 7 dx. So 1/7 du equals dx. And now let's rewrite it. We get the integral of what? Cosine of u over sine of u. du with a 1/7 out in the front. Okay? Nothing wrong with doing that, except that there is no quotient rule for integrals, right? So we would need to do u substitution again at this point, because I still see a function and its derivative, sine and cosine. Okay? So we could do a second u substitution and continue, or we could alter our u to not just be 7x, but either cosine of 7x or sine of 7x. I'm going to show you why choosing sine of 7x would be a better idea. So what is du? Cosine of 7x times 7 dx. Everybody catch up with that. Now, do what? Divide by 7 on both sides. I now have 1/7 du equals cosine of 7x dx. Well, that accounts for everything. U is sine of 7x. 1/7 du is cosine 7x dx. Let's do the rewrite. 1/7 is out in front. Integral of what? Not just 1. 1 over u. Times du. And what is the antiderivative of 1 over u? Natural log. Very good. Absolute value of u plus c. So that gives us 1/7. The natural log of the absolute value of sine of 7x plus c. Yep, I'll show you. So our original was the integral of cosine of 7x over sine of 7x dx. So you could think of this as the integral of 1 over sine of 7x times cosine of 7x dx. That's where you'll see the 1 over u times the 1/7 du. Okay? Now, given situations where we have a quotient, like this one, we know that we can take the antiderivative of 1 over u. So here's another little hint. When we have quotients, consider, not always, but consider the bottom as a possible u. So that's why it changed a little bit from the most inside function, because Kyle was right, the most inside function was 7x. But on different types of integrals, choosing a different type of u would make the problem easier to solve. Any other questions with this? Yeah, Ashley? Nope, because we're taking an antiderivative, right? Antiderivative, gotta go the right direction. We're going the other way now. If we had chosen our u to be cosine of 7x, then we would have ended up with a du in the denominator. We never write integrals with the integram divided by dx. So if you get a du in the denominator, we need to re-choose. We do not want that du in the denominator.
Why? Is it like wrong?
It's wrong. Yes. Because think about what we do. Anytime we take an integral of x dx, we're never dividing by dx, right? We're always multiplying by that variable of integration. So it would be incorrect to be dividing by it. Okay? All right, let's see what's next. Okay, take a look at your, do you guys have your book? Harry, open your book. I'm thinking the page is 56. Sometimes we need to rewrite integrals so that we can complete them. And for that, you will need trig identities. Favorites from years gone by. Now, we're looking for one of the appendices that all of the trig identities. All right. So, trig identities in our text are on page 572 to 573. So, a couple of helpful identities to get us through some trig substitution. Those of you who are going on to Calc 2-3, either here or in college, especially here, Mr. Beamer loves. He loves these trig subs. There's another thing called trig subs. But he loves these u substitutions where you need to change the look of it first, before we even do the u substitution. All right, so let's play with these a little bit. The integral of dx over cosine squared 2x. Can anyone think of a helpful substitution there, before we even choose u? Donna? We could, so we could do 1 minus sine squared on the bottom, right? Is it going to help us? It's not going to help us too much. Other ideas. What is 1 over cosine squared equal to? Secant squared. Well, why is that helpful? So we get this. Why is that helpful? That's right, Jackson. Say it louder. It's tangent. The antiderivative of secant squared is tangent. But here's a little note also. Anytime we have a trig function of something other than just x, so a trig function of f of x, you need u sub. So this looks like it should just be tangent of 2x, but it is not. We need to consider the u sub so we get the proper multiplier out in the front. So anytime it's a trig function of f of x, or if it is e to the f of x, or 7 to the f of x, anytime it's not just x in these places, we need u sub. Alright, so what would be my u? 2x would be my u. Du is what? 2 dx. Tell me what to do now. Divide by 2, because all we want is dx. So now I get a 1/2 out in front, the integral of secant squared of u du. So we get 1/2 times what? Tangent of u plus c, or 1/2 tangent of 2x plus c. I will tell you the most difficult step when we just get started in new substitution is going from this to this. Most times students can see that how I get there when I'm doing it, but when you try it yourself, that's going to be your challenge, your rewrite. So if you're having trouble seeing that at any point while we're practicing, let me know, please. All right. How about that next one? We have cotangent squared 3x dx. So we could think of this as cosine squared over sine squared, but that's going to require a good bit of work. So, Harry, you with the book open, is there an identity dealing with cotangent squared? Maybe a Pythagorean identity. That should be one of the categories. Yes, that's the one. Give it to me again. Why is that helpful? So what is cotangent squared theta equal to? Good. So cotangent squared theta is equal to cosecant squared theta minus 1. Is that a helpful change? We know the integral of cosecant squared, don't we? Yes. So this becomes the antiderivative of cosecant squared theta minus 1. Oh, it shouldn't be theta, it's x. Dx. All right. Now what? We can do this as two separate. Oh, no. I'm sitting here thinking, well, we don't need to do substitution on this one. Yes, we do. This is 3x. Thank you. All right, so now we'll have the integral of cosecant squared of 3x dx minus the integral of 1 dx, just separating it into the difference of two integrals. We know that's one of our properties. And the second one's very easy. What do we get over here? What do we get? Not 0, wrong way. We get x. What did I start with? We get 1. And we'll know we'll have a plus 3. All right. So what is my u over here? U is 3x. And du? Equals 3x. Divide our 3. We get 1/3 du equals dx. Now, what about the rewrite?
1/3 integral
secant squared of u du. All right? And what is the antiderivative of cosecant squared?
Negative cosine.
Thank you, negative cosine. Plus c, so that is negative 1/3, the cotangent of what? 3x. Then we have minus x and plus c. So even when we separate and we get a plus c over here and a plus c over here, it's two constants, and we're just saying we're adding a constant in the end, so you can just toss the plus c on the end of the entire problem. All right, and let's try one more. Cosine cubed x dx. All right, so here is your hint with this one. We want to look for a function and its derivative. So if we rewrite this one as cosine squared x times cosine x dx. Now, Jonna, what is cosine squared equal to? Yeah. You're going to use that staggering one. Cosine squared is equal to 1 minus sine squared times cosine x dx. Now, try that at your desk, please. Homework is section 7.2. I don't know the page number, 1 through 57 odd. It is on the assignment sheet, and I'll update the assignment sheet tonight to get the dates right for your final. All this week, anytime you want to come in and go over any topics from the semester, please do.
Yeah.